The world's population is growing rapidly, leading to a scarcity of natural resources. However, there is a potentially untapped source of resources waiting to be harvested, and it is not on our planet. This is the world of asteroid mining. According to Neil deGrasse Tyson, if you want to be the first trillionaire on this planet, you need to be the one who mines asteroids for materials. But it's not just about being wealthy. Moving resource extraction into space might relieve strain on Earth's ecology and potentially pave the way for human habitation of other planets. To put it mildly, this is a logistical nightmare. But how do we make it work? Even so, is it worthwhile? And once we harvest the riches in space, what do we do with them? In this video, we'll look at the amazing potential of asteroid mining, how it may change the course of human history in ways we could never have imagined, as well as the possibilities and difficulties associated with this difficult task. The surface of the Moon or Mars is not thick enough with the good stuff to be viable, and asteroids are the nearest and most valuable natural resource in our solar system. The cost of creating and building a mining rig that can go into space will also be exorbitantly high, thus the payoff must be just as large. Since the finest resources are all buried too deep under the surface of planets, they are the worst objects in the solar system to mine. The gravity of the Earth drew all the heavy metals into the molten core during formation, leaving just a small fraction in the crust. Yet throughout billions of years, asteroids struck that crust and added their supply of these metals back to the Earth's makeup. So, all of the uncommon but priceless metals like gold, cobalt, nickel, iron, platinum, and others found in the Earth's crust were struck by asteroids after the planet was created. We've already been able to identify a few asteroids in the area that could be worthwhile to mine. Bennu is one such case. In the next 100 years or so, this is the asteroid in the solar system that is most likely to strike the Earth and wipe out the whole human race. It is mostly constructed of iron, which is both very useful and inexpensive. Bennu is said to be worth over $700 million, which is a substantial sum. But is it worthwhile to pursue by creating a whole space mining industry? Very likely not. Then we got Ryugu. The Japanese space agency has been investigating this asteroid, and it is currently believed to contain several valuable commodities, including nickel, iron, cobalt, water, nitrogen, and hydrogen. Given that Ryugu is accessible and has an estimated worth of around $80 billion, analysts estimate that after deducting the cost of a mining operation, the asteroid may provide a profit of roughly $30 billion. That's nice, but even if you did have $30 billion, you still wouldn't be as wealthy as Elon Musk or Jeff Bezos, who hasn't even traveled to space yet. The next target was asteroid 16 Psyche, which is perhaps the biggest and maybe the most valuable asteroid in the solar system. This asteroid is located in the belt of asteroids between Mars and Jupiter. The solar system's most expensive asteroid, 16 Psyche, is said to be worth $10,000 quadrillion. It is thought to be the formed core of a dead planet that sheds its outer layers and is thought to contain the super valuable metals platinum and gold as well as nickel and iron. To uncover more riches than the whole world economy, space miners are pursuing this asteroid. But is asteroid mining even legal? No, it isn't. But according to a law called the United States Space Act, which was created in 2015, American businesses are permitted to own the elements they extract from asteroids. The apparent issue with this entire plan is that once we have unrestricted access to commodities like nickel, they lose their rarity and thus their value. Of course, it's more complicated than that since, even if there would be a plentiful supply, access would still be limited because gathering and bringing back would involve space travel. The SpaceX Starship, with an anticipated cargo capacity of 100 metric tons, is the closest thing we currently have to a viable interplanetary freight carrier, even taking into account the restrictions of a spaceship's carrying capacity. For asteroid mining to catch up to Earth mining, which would need an average of 70 Starship launches per day on a round journey that would likely take 2 or 3 years to accomplish, the annual nickel output on Earth in the year 2020 was 2.5 million metric tons. So, we wouldn't precisely call that situation feasible. It's a serious puzzle that requires a lot of thought. and we may not be ready to solve it just yet. In 2003, the Japanese Space Agency launched the Hayabusa mission to investigate neighboring asteroids. The Itokawa asteroid was visited by Hayabusa 1 in 2005 and returned to Earth on June 13, 2010, carrying microscopic granules of asteroid material as samples. To investigate the Ryugu asteroid, gather samples, and return them to Earth in 2020, the Hayabusa 2 launched in 2014. Because of its tiny size and low weight, a probe may easily approach an asteroid and establish contact with it. Nevertheless, ion thrusters lack the power output necessary for rapid acceleration or deceleration. This is not appropriate for a massive mining vessel like the spacecraft required to establish a mining enterprise on 16 Psyche. For the spacecraft to reach the necessary speed to travel the distance in a fair length of time, and for the engine to fire again with enough force to stop the ship, we need an equally large rocket engine. Yet, unlike Earth, asteroids don't have gravity or atmospheres to aid with deceleration energy. The largest and densest asteroid we are aware of is called Psyche, and it possesses a gravity of 0.06 meters per second squared as opposed to the Earth's 9.8 meters per second. All the others have a less gravitational pull, or more accurately, none at all. It poses a significant obstacle to mining an asteroid. The simplest method we are aware of for mining rocks on Earth involves drilling a lengthy hole, inserting explosives, and then detonating a massive explosion that shatters the rock. We then remove the broken pieces of rock. Nevertheless, if we attempted that on an asteroid, all the debris would just launch into space. Whatever rock we dislodge from the asteroid's bulk won't remain there. So trying to work that out is simply logistical madness. We would need some kind of vacuum machine/rock crusher hybrid. An additional insane concept would be to capture an asteroid, use cables to attach to it, and then return it to Earth's orbit. We could take resources without letting them drift away if we set up a mining rig on an asteroid and begin transporting them back to Earth. We may shatter the moon into little bits and process it on the surface if we collide with it. The closest approach to a functional spacecraft is the SpaceX Starship, which can take off with 100 tons of payload. With so much weight inside of it, SpaceX is convinced the second-stage Starship will be able to touch down on the Moon and Mars. A fully loaded Starship could probably do its landing trick on Earth, although it seems implausible. We could construct a massive spacecraft, similar to a scaled-up version of the one that transports people to Earth, to bring them here. It may land in the water and be able to float there thanks to an enormous parachute the size of New York City. There is a weight restriction on how much we can dump into the water, and anything substantial enough to be helpful would set off a massive tsunami wave. Yet, a solution must exist. It is now generally acknowledged that if we are going to utilize resources in space, we must also extract them there. Water is a simple winner, since there is a lot of it within asteroids in the form of ice. In addition to being essential for drinking, astronauts also need water for their radiation shielding and to rehydrate their space meals. A bottle of water's worth of water may cost up to $43,000 to get into orbit, making it more cost-effective to get water in space than to attempt to send it in a rocket. In the asteroid belt between Mars and Jupiter, there is a dwarf planet named Ceres. There is possibly more water on that planet than there is on the whole planet Earth, according to images from the Hubble Space Telescope. The water should also be reasonably simple to remove. We might focus heat from the sun to practically burn the water vapor out of the rocks and collect it using a method known as optical mining. The most practical method to construct spacecraft is by extracting water from asteroids, but as a civilization, we're still a long way from there. Though Elon Musk is not very enthusiastic about deep space mining, calling it quite fake, and claiming that the economics don't make sense if you include the cost of bringing the raw material back to Earth. Yet, two sizable businesses have been established in the last 10 years specifically for deep space mining. Planetary Resources, the first asteroid corporation, was established in 2012, and a year later, Deep Space Industries, a company based in the United States, also appeared. Even yet, the debut of their websites was unsuccessful. A self-sustaining civilization on Mars is Elon's grand vision for mankind in the 21st century. He views it as a trillion-dollar opportunity. But still, according to the scientists, asteroid mining is one of the next big things for us, particularly when we will be done with the resources from Earth. Space mining will be the only available way to save mankind. What do you guys think, though? Is space mining a scam or the way to untold riches? If it is feasible, how can we bring it to the surface from here? Please share your theories in the space provided below. Don't forget to subscribe to our channel and turn on the notification bell to know about more incredible facts. Thanks for watching.